Our speaker tonight is Dr. Carey Garland. He received his PhD in anthropology from the University of Georgia in 2019. The following year, he took a postdoctoral position at the University of Georgia's Laboratory of Archaeology, and in 2023, he was permanently hired by the Lab of Archaeology and recently promoted to an assistant research scientist. Carey Garland continues to direct the Archaeology Field School and conduct research and train students in archaeological field and lab methods, with an emphasis on indigenous histories along the Georgia coast. Thanks again for being here, Carey. Let you take it away.
Great. Thank you, Jamie. Go ahead and share my screen. All right. Yeah, thank you for having me. Thanks to Jamie and Rachel for inviting me. I'm happy to be here and talk about some of my research on the Georgia coast, specifically about the Hokfv Mocvse shell ring, a little bit about coastal resource management and the rise and fall of late archaic shell rings on the Georgia coast. Um, so this, what I'm going to be talking about today is kind of a combination of many different projects over the years, more recently stemming from an NSF grant, as well as our field school in 2022, a few years ago, when we identified this new shell ring, the Hokfv Mocvse shell ring. But before I start, I want to just kind of give there we go. A little overview of the presentation today. So I want to start off just talking a little bit about late archaic shell rings and what they are. A little bit about our research coming out of these shell rings, especially regarding collective actions and institutions revolving around coastal resource management. And then a little bit about the rise and fall of these shell ring villages along the Georgia coast. And I'm going to use Hokfv Mocvse as a case study of one of the earliest known shell ring villages in this area. So we know that adaptation to coastal environments was a really turning point in human history, like across the globe, though occurring at different environments and different times. On the Georgia coast specifically, we see the adaptation to coastal settings, kind of involving the shift to new socio-ecological systems. So this kind of shift to new marine-based economies, as well as sedentary life, starting around 5,000 years ago. We also start seeing this kind of evidence of management of coastal ecosystems and marine-based resources through collective action and cooperation. And I'll talk a little bit more about these different ideas as we go through. But a lot of what we know about this kind of shift to coastal settlement and working in these managing these coastal ecosystems come from these late archaic shell rings that we see really across the whole southeast. So these are cultural sites that date from the late archaic, so around 5,000 to 3,000 years ago. There's some down in Florida, closer to home for y'all, but the vast majority of them up on the Georgia and South Carolina along the coast. So there's around, I think, over 50 of these shell rings that have been identified in the southeast. They vary in their size, they vary in their shape, as you can kind of see here in this image. Many of them are circular, some of them are more arcuate shaped, so like half circle. Then you got some weird ones like the Skull Creek. It's kind of shaped like a figure eight. So again, a lot of these are what we know about these early coastal adaptations, specifically on the Georgia coast, come from archaeological data and research into these shell rings, these shell ring sites. So I'm going to really focus today on the Georgia coast. So we have this map here on the left, kind of showing the Georgia coast. The Georgia coast is made up of a few these large barrier islands, as you can see in the map. Each of these islands have like an older Pleistocene core that dates to like 40,000 years ago, and a kind of a more recent Holocene beach core that dates to around 5,000 years ago. And these barrier islands are separated from the mainland by pretty extensive estuaries, so tidal creeks and rivers, which provides really dense kind of marine resources in this area. So we have a lot of these shell ring village or these shell ring sites on all these islands from up at Ossabaw down to St. Catharines and Sapelo. One of the more kind of well-studied one is the Sapelo shell ring complex on Sapelo Island. This has three different shell rings. The one of them is shown here in the middle image in this LiDAR. It's a really nice looking shell ring. Um, there's been a lot of research that's been done there ever since like the 1950s. So we've learned a lot about these shell rings in this time period from the Sapelo. So these shell rings, they largely consist of mollusk shells. Generally, they're around 80-90% oyster shells, but we do also get clams and mollusks as well. Um, there's been a lot of different arguments about their function. So some have argued that they are the product of like ceremonial feasting. So people in that area will gather and have feasts. And then you get this kind of deposition of shell. And others have argued they're more representative of habitations in village life. I mean, it's possible that different sites have different functions, or that they even changed over time. But most of the evidence has kind of pointed to them actually being areas of habitation. There's been some studies doing radiocarbon dating that has showed that the shells accumulated gradually over time, which is in contrast. If it was from feasting, we would see like a really quick accumulation of shell when people are gathering and eating and disposing of the shell. So we've kind of shifted this, really idea that many of these, at least on the Georgia coast, were habitation sites, and even sedentary, permanently occupied year-round villages, which I'll get more into in a minute. And some of them are quite large. The Sapelo Shell Ring one, as you can see, is about 90 meters in diameter. I think at its height, it's around 3 meters high. So this is the image I took while I was there last summer, as it kind of going into this entrance way. You can see the shell piled up on the sides, some 9 feet high. So they're quite impressive sites. There's some other big ones, such as the Fig Island in South Carolina, Fig Island Ring 1, which is shown in the slide on the right, which I believe is about 5 meters high. So it's quite large as well. It's interesting, too. It has these kind of ringlets in the back, which we see at many of these shell ring sites, these smaller circular ringlets kind of extending off some of the sides of the shell ring. And another interesting thing is these sites are also associated with the earliest pottery in North America, at least north of Mexico. So many of you are probably familiar with this late archaic Stallings Island or St. Simon's Island pottery image, shown here. One on the left, a punctated one. Again, this is some of the earliest pottery in the region in North America. It's fiber tempered, so it has this pretty classic kind of lines in it from where the fiber burnt away when it was heated. Often, tempering it with things such as like the saw palmetto or the Spanish moss. So a lot of these sites again are associated with this new technology as well, with the inventions of ceramics. So a lot of our recent research into these shell rings on the Georgia coast has really been, moving away from these kind of just simply viewing the communities that lived here, the ancestral Muskogean communities that lived here, as just being hunter and gatherers, mobile hunter gatherers, just more thinking about um, social institutions and examining how people lived together, how they came together and lived together and got things done. Again, as a specialist, I'll talk in a minute, is how evidence that people were living at these shell rings, year round. So this new kind of sedentary life. So these circular shell mounds, we're arguing reflect kind of a complex village life with cooperative labor, long-term traditions, and coastal adaptations. Really, especially like kind of regarding the emergence of institutions focusing on managing common pool resources and marine resources. So the oysters being one of the primary resources. Oysters are a common pool resource, so they're kind of collectively harvested by people, but they have the potential to be over harvested. However, it doesn't seem like people were over harvesting oysters. There's actually a lot of data to the contrary, that they're actually sustainably harvesting oysters in spite of actually large scale harvesting. A few kind of lines of evidence for this. One is just the persistence of some of these large shell sites in the southeast. Even across the globe, we have lots of evidence that indigenous people were harvesting shells at a large scale and doing so sustainably. A good example, kind of closer to home to y'all, is Mound Key down near Fort Myers, which is a completely anthropogenic island. We've done some kind of LIDAR and kind of volume estimations of the island to see how much oysters there. We got kind of nerdy and did some math and have kind of estimated that the island is probably made up of around 22 billion mainly oyster shells. So they were harvesting shells quite extensively and still seem to be protecting the health of oyster reefs. Another way we know that they are sustainably harvesting oysters is through oyster paleobiology. So looking at the size and shape of oyster and how that's changed across time. So if you look at oysters now, we know like in the late 1800s, we have capitalist oyster fisheries and canning of oysters, kind of over exploitation of oysters has kind of led to the demise of many oyster reefs along the Georgia coast and kind of eventually led to very small oysters. There's been a lot of, innovation now to try to bring back a lot of these and restore a lot of these oyster reefs. Um, but we actually, looking back through time and looking at the size of oysters, we see that oyster size stayed relatively same across time, if not increasing. So a few colleagues and I have quite a large database on oyster size data. I think we have over 50,000 measurements from shells from sites across Georgia and South Carolina, covering time spans from the late Archaic up into historic periods. And what they largely show is that oysters' size has stayed stable across time. So usually you expect with overexploitations and poor environments that you may get a reduction in oyster size. Another way we can look at oyster harvesting and shellfish harvesting practices is through oxygen isotope analysis. I'm not going to get into all the nitty and gritty chemical aspects of this, but just in a nutshell, or as an oyster shell is my lame joke. Oxygen isotopes in shell reflects the oxygen isotopes in water that they grow up in, and then oxygen isotope values in water reflects two things. It reflects temperature, and it can also reflect salinity levels. So we can actually do analysis on shells, look at the oxygen values in shells, and look at things such as like local environmental change, so changes in salinity or water temperature. We can also, again, use this to look at Native American indigenous shellfish harvesting practices, such as when they were collecting the oysters and the range of habitats used. So this top image here kind of is an image of me milling an oyster shell. So this is, you think of just of a sectioned oyster shell. And what we do is we take these kind of incremental samples from the oyster, which can represent anywhere from a year to 2 years of their life. And we'll do isotope analysis on each one of those samples. And here, where's my where the last sample is basically where the oyster was at when it was captured. So that's kind of reflects time at capture. So we take this data, we create these graphs, and you generally get this sinusoidal pattern. So each of these reflects one oyster shell, the sampling from one oyster shell. So you get these kind of oscillating patterns reflecting changes in water temperature through different seasons. So usually in the winter, you have higher isotope values, oxygen isotope values, In the summer, you have lower oxygen isotope values. So in this case, the first sample represents when it was captured. So there's a couple things we can do here. We can look at this first value to actually identify what season the oyster was captured. Um, we can also take the summer value, so the lowest value, and we can use it to estimate salinity. So we can estimate the salinity and specifically where the oyster within the estuary lived at. So what this tells us, one is for seasonless capture. This is one of the evidence where we have used to argue that people were living at these late archaic shell-ring villages year round because we have oysters that were captured all year round. Often they were, preferentially harvested in winter, but we do have lots of oysters and clams as well that show year-round capture. Again, that they're living there year round. We can also, again, estimate the salinity that the oysters, where they were in the habitats. So one thing that's about the Georgia coast is we have salinity gradients. So we have these estuaries and these rivers and tidal creeks where the water closer to the open ocean is much higher saline, and the water closer to the freshwater rivers is going to have much lower saline. So one of the things we do is we go in these areas, we collect a lot of water samples, and we check the oxygen isotope and the salinity values of those water samples. We create a simple regression and get a regression formula so we can see the kind of correlation between the oxygen isotope value and the salinity value. So then we can take the salinity data from the archaeological shells, plug the oxygen isotope values into those regression formulas and estimate the salinity of the water that the shell grew up in. So one thing that's allowed us to do is see where in the estuaries that the oysters were harvested from. If they're living in a shell ring, they probably have plenty of oyster reefs right there adjacent to their shell ring. But a lot of the data shows that they were going throughout the estuaries to collect oysters. They weren't just targeting one specific reef near their village. They're traveling throughout the estuaries. We have ethnographic data that they could have been traveling up to 20 kilometers per day via canoes and accessing and harvesting from a range of different oyster reefs. So these are just estimated salinity values kind of collapsed from a bunch of different rings on the Georgia coast per different island. So you can see you got Sapelo Island and St. Catherine's Island showing quite a range of salinity values from, some as low as 15 to 20, which would be closer to the freshwater rivers, and some up to closer to 40, which would be closer to the open ocean. So we think this was one way that they were sustainably harvesting oysters. Again, rather than targeting and depleting oysters right near the village, traveling around and harvesting from a bunch of different oyster reefs throughout the surrounding estuaries. Another way we can think about these institutions is just in the circular layout themselves. So we actually see a lot of circular villages throughout the Southeast, predating late Archaic. And there's some arguments, again, that this represents an institution. If you're in a circular village, you can see your neighbors, you can see what they are harvesting and bringing back. And it's a way, to ensure social equality and making sure that there's no, self behaviors that are, people that are harvesting and bringing back too much, basically. So we have a bunch of these different ideas about these different institutions and rules of how these early villagers were interacting with their environment and sustainably harvesting oysters. I forgot to mention a lot of, another thing you see with all these islands is differences, not only in the salinity, but also in shell size, which we've also argued may reflect like different territories, right? So communities across these different islands had different fishing territories, so that again, not everyone was going to the same place and over harvesting. So a lot of our kind of research over the last few years has really um, been thinking about coastal resource management and again how people are coming together in these sedentary villages, living together and cooperating and making sure again that they're sustainably um, managing their ecosystems. Um, so I want to talk the rest of the time a little bit about this kind of just the history of these late archaic shell ring villages and their rise and fall. So starting with um, here, in addition to these large isotope data and shell measurements, we've also some colleagues and I have amassed a pretty large radiocarbon database as well for shell ring sites across Georgia and South Carolina. Um, so you can see in this image, these are just modeled radiocarbon dates for individual sites. The vast majority of the shell rings um, were between 4,300 and 3,800 years ago. They seem to be kind of at their apex around 4,200 years ago. Um, but we do have a couple later lasting ones and a really earlier one, which I'm going to focus on for a little while now, which is the Hokfv Mocvse shell ring, which is dating up close to 5,000 years ago. So Hokfv Mocvse shell ring on Ossabaw Island. It's on Ossabaw Island, Georgia. We identified it in 2022 during a field school. We did some excavations then. Since then, we've done some isotope analysis, oyster paleobiology, radiocarbon dating. We've had some colleagues go back and do some remote sensing there as well. And it's really providing some insight into the nature of one of the earliest known settlements on on the Barriers Island. Um, so before this, we thought that the earliest sites in this region were probably 43, 44, 4,500 years ago. We assumed there was probably early ones that maybe we just couldn't see because of rising sea levels. But this new shell ring has kind of given us a glimpse into the earliest, known settlement of the island. So again, this was identified in 2022. A lot of our my research and colleagues' research has been in collaboration with descendant communities, especially Muskogee Creek Nation, whose ancestral homelands are the Georgia coast and all throughout Georgia. So they're the ones that actually named the shell ring. So Hokfv Mocvse is actually Muskogean for new seashell. Um, so I'm going to talk a little bit about our kind of excavations and how we identified the site. Then get a little more into some of this data on like isotope analysis data, oyster paleobiology, kind of getting into a lot of things I've just discussed about what it tells us about um, resource management and the kind of timing of settlement on the Georgia coast. So Ossabaw Island, again, it's one of the major barrier islands on the Georgia coast, just south of Savannah. It has quite a long archaeological and human history. There's been a lot of archaeology, even early with C.B. Moore in the 1800s. Again, we know that people were living there at least by the late Archaic, um, and again, maybe earlier, but likely obscured by sea level. But we do have some other shell rings there, such as the Ossabaw shell ring. Um, and the Hokfv Mocvse is located the site of Blufffield, which is on the northern end of Ossabaw Island. So this Blufffield is actually where we were focusing on our 2022 field school. And the reason that we're focusing there is because much of the Georgia coast, the islands, are at risk from erosion due to increased storms, rising sea levels. So we're unfortunately losing a lot of cultural sites on the Georgia coast. So a lot of our research has really been geared towards documenting sites that are in danger of being lost. So we decided to focus on Blufffield, which is actually a woodland to Mississippian, so 1,000 up to 500 years ago site. It's a bunch of low shell midden mounds there. But we first started doing some shovel tests and units there. And our first week, while students were excavating, we were just kind of walking around, probing, having fun probing around. And we identified what we thought was a large circular ridge, um, kind of located at the Bluff Field site. And then we went back that day and looked at the LiDAR, and lo and behold, if you can see over here on the right, and we looked at this LiDAR so many times planning for field school, but never noticed the circular kind of feature there. So I was like, okay, we definitely got a circular shell ring. Um, so while students were kind of excavating some of these units over here, so this is kind of the main woodland Mississippian occupation of Bluff Field. There's a large mound there too that was documented by C.B. Moore in the late 1800s. That's not a shell ring. That's actually a mound. So we were doing units and shell test over here. Then we decided to do some units, or started doing some shell tests over here on the shell ring too, just to kind of start exploring what was there. So the ring, it's not a large one. It's only about 40 meters in diameter. It's pretty thin too. I think at the thickest, this is a profile of one of the units we eventually did on the shell ring. I think at the thickest it was about 60 centimeters. So only, not too, it wasn't too high. It was definitely a very small shell ring. Um, and we're not sure if it's circular or if it was half circle, because it also was eroding quite bad. You can see at this line here where the creek is eroding into the land. We get a lot of erosions on the Georgia coast where you have these really fast bending turns in the creek, which really kind of cuts in. I think this area is eroding around a meter a year, so it's quite extensively being eroded. Um, so we started doing some shovel tests there. Um, and because it was also eroded, we eventually did 4 1 by 1 meter units, and continued doing shovel tests along the arm of the ring and a little bit behind the ring too. There's looks like to be some ringlets back there, kind of like I showed at Fig Island as well. Um, but very quickly it became quite interesting because we didn't find any ceramics. There were a few ceramics on the surface, some later dating like woodland Mississippian period ceramics. There are a few scattered in that topsoil level above the shell rings, but there were actually no ceramics within any of the kind of the shell part of the ring. What we did find also interesting was 4 PPKs, very similar to Middle Archaic to kind of early late Archaic stemmed quartz PPKs that we see in the Savannah River Valley, very similar to more mountain PPKs as well, which are middle Archaic. So 8,000 to 5,000 years ago, much older than most of these other the shell rings. There have been some similar shell rings found, again in this. I mean, projectile points of this type found in the Savannah River Valley, dating to 4,800, 5,000 years ago. So these two things were very interesting. We don't find too many lithics on the Georgia coast. There's not too many lithic outcrops. When we do, it's generally coastal plain chert. So it was very interesting to find quartz, also to find really old ones. So we didn't find much cultural material within these units from the shell ring. So we had to convince the students that it was very fascinating. We knew it was really important, but of course, students, they really want to find ceramics and things. So we had to really like sell it like, hey, you're not finding anything, but that's actually super cool in this case. Um, so at this point, we knew we had a shell ring, and we knew it was an old shell ring, likely, obviously predating ceramics. As I mentioned, most shell rings are associated with those Stallings Island, St. Simons, late archaic fiber tempered pottery. So then, of course, we decided to do radiocarbon dating, and it actually fit our expectations. So we have a start date at around 5,000 to 4,800 years ago, and an end date 4,800 to 47,000. So just say roughly the site dates between 5,000 and 4,800 years ago, which kind of matches, right? That predates ceramics and is kind of similar date to some of these older or other quartz projectile points in the Savannah River Valley. So again, this predates all the other shells. Actually, predates most of them by 400 years, which is interesting. We kind of have at this point still have a gap between the Hokfv Mocvse and other shell ring villages on the Georgia coast. But as of right now, it is the oldest known shell ring in this region of the Georgia coast. So um, again, can provide some pretty good insight into early coastal adaptations being one of the earliest known cultural sites on these barrier islands of the Georgia coast. So again, stemming from this project, I continue to do more isotope values or isotope analyses and shell measurement analyses as well. Again, one of the first things we did while we were there, I kind of already showed this image, but we collected modern water samples. That way we can have a kind of oxygen salinity relationship local for the area. We have other ones such as Ossabaw Island and some further north, but we wanted to want some specifically for Ossabaw Island. And this gave us again a regression formula that we could use for the archaeological shell isotopes. So that data, as similar to the other data, one, it shows a wide range of salinity. I have it labeled Blufffield. I think I made this graph before it was renamed the Hokfv Mocvse shell ring. But again, showing pretty wide salinity values in the shells from 21 to 36 PSU. So again, this is, if you got 17 closer to the mouth of the Geechee River, 40 closer to the open ocean. So this kind of fits in their expectations. And so we know that they were using even 5,000 years ago, 4,800 years ago. They may have already had institutions in place and practices in place where they were widely targeting habitats across different estuaries. I didn't put the graph in here, but I found this really interesting. We have a master student who just did similar analyses on archaeological shell from an enslaved context on Ossabaw Island. No one's really done that yet. Really interesting. Had very, very low ranges and salinity values and very high right next to where the plantation was. And they also were primarily winter shells, which really fits into the context with enslaved communities in that at that plantation where didn't have as much time to travel around, so they were just targeting those oyster reefs right near where they lived. Same with the looking at the season of collection. They were harvested year round. Winter was the dominant season, so they're selectively harvesting oysters definitely in the winter. But we have a good number of shells also harvested in summer, in spring and fall. So we know that even by 4,800, 5,000 years ago, people were living on the Georgia coast year round, which is really interesting. We could think it was really early site. Maybe they were moving there, especially with the quartz projectile points, moving there seasonally. But it seems like, based on the isotope data, that they were actually living and harvesting shells year round that were used to make the shell ring site or the shell ring. Sorry, I'm losing my voice. I'm just getting over a cold. We had a GI Whiz colleague also do some back forecasting bathtub modeling of sea levels to kind of look like what the sea levels may have been like during this time period. So he kind of visualized what Ossabaw Island was like at different sea levels from 1.5 to 3 to 4 meters below present. And even, at the current present level of sea levels today. And then we also, along with that, mapped the location of historic oyster reefs. And it seems that these historic oyster reefs, the ones that are documented that we know exist, um, were suitable for, there was suitable areas for their presence 5,000 years ago, even um, at lower sea levels. So we know it even at lower sea levels, we had those reefs and those estuaries were in a place for humans to live there and harvest from them. So the Hokfv Mocvse really gives us some really good insight into the emergence of these late archaics, really early coastal adaptation to the Georgia coast, and again the development of these institutions ranging around coastal resource management, also this kind of shift to more sedentary year-round living. But these sheltering villages, they didn't last forever. As an institution, they eventually waned. I mentioned this earlier. We definitely see their apex around 4,200 years ago, and most date between 4,400 to about 3,800 years ago. And we really see around 3,800 a kind of abandonment of this type of settlement pattern. Again, we see some late surviving ones in South Carolina, which I'm not quite sure about. But the vast majority of them are kind of gone around 3,800 years ago. And I think we really have to look at this in the context of the environment. Um, Here, I'm gonna just focus on the kind of salmony color ones. These are estimated salinity values from archaeological shell from these different sites on the Georgia coast, ranging from the earliest one, the Hokfv Mocvse, to the latest one, the Sapelo Shell Ring 3, which dates around 3,800 years ago. So we kind of see this increase in estimated salinity values and a significant drop of salinity values in the oyster shells from the Sapelo Shell Ring 3, which is quite interesting. And again, we need to think about this in terms of what's going on with the environment. So we have a lot of sea level data out there. This image on the right is showing a bunch of different interpretations or ideas of changing sea levels. So you see here around 5,000, we definitely have this increase in sea levels, kind of setting the stage, I think, for this for humans to live on the Georgia coast, the development of these estuaries. So you got the right mixture of the sea levels rising and mixing with these freshwater creeks to kind of develop these really resource dense estuaries. Again, they stay pretty stable. Around 3,800 years ago, we see a big drop, and especially up till around 3,000 years ago, we see a really big drop in sea levels, which is going to have a big impact on the resources and oysters in the region. With the lowering sea levels, you're getting less salinity, you're getting more freshwater inputs, changing those environments. And oysters and clams, they really need a certain a salinity range to be healthy. So too little salinity, too high salinity, they can't tolerate it as much. So this kind of drop in salinity levels again really corresponds to this drop in sea levels, which we think may be one of the reasons why they abandoned some of these shell ring sites. Another line of data we have this is from Kat Napor, one of our colleagues, who did dendrochronology in the region, and showed that the time that the shell rings were inhabited, we got really high interannual variability in rainfall. But after 3,000, you get overall wetter environment. So you get a lot more rain that's a lot wetter, which also is going to put more fresh water into the estuaries. So with lowering sea levels and rainier weather, it can have likely had significant impacts on local estuaries, lowering the salinity and kind of leading to less productive oyster reefs um, in the region. So there's been some arguments that kind of with this we had an abandonment of the Georgia coast. So this is kind of showing site frequencies from the late Archaic up into the early Woodland, which started around 3,000 years ago when we really see that significant drop in the sea levels. And eventually back in the middle, late woodland, and definitely in the Mississippian, we start seeing a lot more sites. So a lot of people argued that we see an abandonment of the Georgia coast, but we don't think that's necessarily true. We think people remain tied to this geographic place. They just adapted to the environment and used it in different ways. So it seems that people kind of moved more upland, and we see kind of less shell-bearing sites. So my colleague Victor Thompson did a whole bunch of shovel test surveys on a lot of these back barrier islands behind Sapelo. So this is two islands south of Ossabaw, what we were just talking about. Um, and sees that there are actually quite a bit of sites in the late archaic period, and even into the woodland. But we start seeing less shell bearing sites, and the majority of them are are linear and not like a circular arrangement. So people are adapting to these changing environments, and kind of shifting the way they did things, shifting institutions and how they kind of um, in, you know, worked and lived in these environments. Couple more. So just in conclusion, as I mentioned, the adaptation to coastal environments was definitely a significant turning point. In Georgia, we get these new socio-ecological system, new ways of engaging with marine resources and managing them. We also see the shift to sedentary village life, which has been kind of the opposite of these long-held ideas about hunter-gatherers in the region, that they are very mobile and simple. So we actually know that they're living in more, complex groups, working together and had institutions. Um, and these shell rings, again, were long thought to appear alongside changes in technology and the invention of pottery, as well as the establishment of oyster fisheries. But as I mentioned, the new evidence from Hokfv Mocvse shows that they actually predated pottery and that oyster reef management may have began earlier than we thought. Um, so these shell ring villages functioned as long-lasting social institutions with circle layouts promoting cooperation and collective action, as well as sustainable management of oyster and other marine resources. And this persisted, for 1,000 years, from 5,000 up to 3,800 years ago. Hokfv Mocvse may have significant implications, again, for our understanding of Georgia human and natural history, especially into the earliest settlement of the Georgia coast, at least that we know now. Um, and again, earliest sedentary villages in the regions and possibly early institutions in place for sustainable shellfish harvesting, with again the emergence tied to sea level change, and the emergence of productive oyster reefs around 5,000 years ago, as those sea levels were rising, and again, the development of these estuaries that were suitable for productive oyster reefs. But again, around 3,000 years ago, the environment changed again, increasing rainfall, I should say lowering sea levels, significantly impacted the Georgia coasts and oyster reefs. And around by 3,800 years ago, ancestral Muskogean people of the area again shifted to other socio-ecological relationships, as evidenced by more non-shell-bearing sites and more upland settings. So again, as I mentioned, they were invested in the geographic locations and were just adapting to these changing environments, and continued to occupy the Georgia coast for thousands of years, in different ways, though. And I think that's all I have. Always my acknowledgments. Georgia Department of Natural Resources, which owns and runs Ossabaw Island with the Ossabaw Island Foundation. Also have to thank the Muskogee Nation. They're always providing input and working with us as we are trying to learn more about their history and conduct research in their ancestral lands. And of course, the 2022, I know it's almost 4 years ago now at this point, field school students who did an awesome job there. And that is all I have.
Excellent. Well, thank you so much, Carey. Very interesting. We'll go ahead and open it up for some questions. If anyone has any, feel free to. I think it works best if you type them in the chat. And I did get messaged a question during your talk, so I'll just ask it to you, Carey.
Sure.
From Anna Gingrich. She said, "Thanks for an interesting talk. What is the thinking on why people harvested oysters primarily in the winter? Were they familiar with the R-months rule?
There's a bunch of different ideas about why winter. One, of course, other resources may not have been available. We know that during the hot months, there's more likely to get bacterial and other infections from oysters. We don't know. It'd be an interesting, if we actually had indigenous people still living in the area to understand these practices better. But yeah, there's been different reasons. Maybe it was ceremonial reasons that were happening in the winter months. It's interesting. It seems to be just oysters. Clams seem to be spread out a little more evenly across the seasons, which is interesting as well. So I don't know if that answers the question, but yeah, there's been different ideas.
Yeah, that is pretty interesting about the clams.
Or taste. I think you've done some research, right? They
Yeah, a
taste
little bit of
better.
taste. Yeah,
Yeah,
they do taste different in the winter. They're supposed
yeah.
to be like a little quote unquote crispier if an oyster can be crispy. Um, that's what the
I'm gonna
farmers
admit
say.
I don't like oysters, and I've never eaten an oyster. I've been studying them for years. I've measured tens of thousands of them.
You've never
So I
had
can't
one?
answer the taste question.
All right, looks like we have another question. How did they determine when the oysters were harvested?
Oh, again, that's going back into here. I can go back into the um, these individual shell isotope values. So again, we get this fluctuation, this oscillating pattern, which reflects different seasons. Again, the oxygen values really ties into the changes in the water temperature. So during the winter months, you have much higher oxygen values. In the summer months, you have much lower oxygen values. So what we can do is we can look in this case that the very first value, which we know was when the oyster died, when it was captured. Um, so we've developed a way where we basically divide this into thirds. If that data point is in the top third, we know is winter. If it was in the middle, it was either fall or spring, depending on the direction it's going. And if it's in the summer, it would be if it's down on the bottom, it would be in the summer. I hope that makes sense. So it's
Yeah, I think your name is Havis or Havis. I believe you were talking about seasonality, but if not, if you were talking about maybe the age with radiocarbon dating, if you want to clarify that. But yep, thank you for that question. And then,
yeah, we generally don't radiocarbon date the actual shell because we got a marine reservoir effect where we can get really old looking shell. So I think in all these cases we've dated hickory nut, like short-lived botanicals, from the same, stratigraphic layer as the shells. And we generally will do like um, radiocarbon dates on multiple different levels that we can kind of really kind of fine tune the radiocarbon modeling.
okay, looks like we have a question from Mark. With rising sea levels, is there any instance or situation that would call for mitigation of a site, or are you only recording and releasing? Recording and releasing.
For us, we're really just recording, but yes, there are some cases of mitigation, especially really important sites. So I know someone on Ossabaw, they're planning on doing like riprap in some areas that are eroding really fast. Um, thing is, it takes a lot of money, and it's for some reason it seems like it takes a lot of time. Those things are kind of held up. um, but yeah, so I know some places they are actually trying to prevent the erosion, but I think the first thing that we know we can, at least as an archaeologist, can do is document it and record it. So we're now working on Wormslow, is where we're doing our field school, um, which is near Ossabaw Island and also eroding quite bad. So it's kind of like one of the first things we're doing is trying to map all of the eroding shell middens, shell sites, um, and do some shell tests and units if we need to. Yeah, some of these cases, some of these, like I said, some of them are eroding like a meter half a year. And those cases would be and are impacting some significant sites, such as the mission on St. Catherine's Island. There's a big mission site, St. Canada, Big Wale, on St. Catherine's Island, which is one of the a big important Spanish mission, um, and indigenous Wale cemetery there too. And it's I know there's been some talk of mitigating um, that erosion as well.
Yep, definitely a problem here in Tampa Bay too.
Yeah, I would imagine
Yes.
imagine so.
Rachel's question was also
You
about erosion, and
answered
it
it.
was the same exact time. So great minds think alike. And then we had another question from Anna. Is it possible that there could have been earlier shell rings further towards the sea that were subsequently submerged by sea level rise on
Yeah,
those later islands?
as I was talking about, we have that kind of gap, and well, for one, we do have earlier pre-shell ring radiocarbon dates, so we haven't done much with them, so we do think people were definitely living there. We have some dating to like the 6,000s, 6,000 years ago. But again, we have this kind of gap, and that's my guess is that some of them are out out in the estuaries or out that are covered up by rising sea levels. So that's the only thing that makes sense to me. I mean, because they're already Hokfv Mocvse 5,400 years ago already predates these 400 years, and it already seems to be evidence that they were adapting to those coastal resources and learning how to manage the reefs. So they had obviously been there, some time for that for that knowledge. Um, so yeah, we've talked about doing another project where we try to identify some more shell rings. I'm not sure what that would look like if they're submerged.
Yeah, just relatedly, is the towards the sea, is there any marsh or is it just like the
No,
Atlantic?
it's kind of beach. It's
Okay.
just yeah,
Yeah.
'cause you got this Pleistocene core, which is always split by the marsh estuaries in the middle. So you kind of got like this middle estuary, and then you got the estuaries between the island and the mainland. So towards the sea is really just, at least on this part of the Georgia coast, it's just beach. So
Yeah.
most of them are in this Pleistocene core, either on the side, the west side, West Marsh, or the inland estuary. But they could just be out in these estuaries somewhere if those were probably at one point, land. Here, I can make this big so you can see a little better.
Thanks. Yeah, definitely. In Tampa Bay, the Kendall Jackson, a lot of his research is on submerged sites and
Hmm.
finding them in open water, under marsh, under mangrove. Sometimes you get lucky in these high energy
Yeah,
marine environments where you maybe wouldn't expect sites to preserve. They're pretty resilient.
yeah.
Do we have any other questions?
I have one. I'm sorry. My audio is being low. Is the field school exclusively for work? It's available to anybody.
Did you capture that, Carrie? You kind of broke up, Mark, but for
Oh,
me,
I'm sorry. Hang on. Let me move closer to the
Oh, we lost you again.
I
in USF. Okay.
I think what I heard, Mark, correct me if I'm wrong, is the field school open to people outside of University of Georgia?
Yes,
Yes.
yep. It's open to anyone. So,
Oh, that's excellent. I'm attending one now.
oh, you're still breaking up. Hey, Jamie,
From
why don't I send
maybe,
you a flyer for the field school?
yeah,
Yeah, that works.
Maybe we can, if Mark wants to, and maybe provide my email. I can put my email in the chat or something if you want to
Yeah,
email me, Mark.
yeah, that'd be excellent. Thank you.
You're welcome.
thanks, Mark. Oh, we had a question from Anne about the site name. Was it New Seashell, right?
Yes.
New Seashell. I like that.
Yeah. That's been a thing. We're trying to, have the Muskogee name the sites in the Muskogean language. So we actually did a new one on Wormslow, and they told us to name the site and the students to name the sites, and they would translate it, which I thought was kind of cool. It was kind of a joint effort.
Yeah, that's nice. All right, last chance. Anybody else?
I put my
Okay.
email in the chat in case somebody else.
All right, thanks, Gary. So I think we'll go ahead and call it a night. Thank you again for excellent talk and for sharing your research with everyone. Really appreciate it. Thanks for your time. Thank you all for joining us, and Happy New Year.
Yeah. Thanks to everyone. I was glad to be here and talk about my research. So.
All right, thanks, everyone.